Hey everyone, welcome back to our YouTube channel Code Streak Daily. In today's video, we are going to solve today's problem of the day of Geeks for Geeks, and today it's 3rd October and we've been a problem majority vote and the difficulty level is medium. So now let's get into the problem. Let's see. Yeah. Let me read the description. You're given an array of integers. The array named nums, where each number represents a vote to a candidate. Okay, return the candidate that have votes greater than one third of the total votes. If there is not a majority vote, return -1. Okay, there's a note given for us. The answer should be written in an encroaching order. That means the array should be written in a sorted way. So let's see. Here we have an array 2 1 5 5 5 5 6 6 6 6 6. And the output is 5 and 6. There is explanation. 5 and 6 occurs more n by 3 times, more than n by 3 times maybe. So here the length of the array will be 1 2 3 4 5 6 7 8 9 10 and 11. Okay, 11 by 3, so it must be more than 3 approximately. It should be around 4, but if we take the value as integer, so it should be greater than or equal to 3, or as it is said more than, it should be greater than one third of the total votes. So it should be greater than 3 here, as we have 5 is given, 5 occurs 4 times and 6 occurs 5 times here. So as it is greater than 3 times, 5 and 6 have the majority vote here. Here we have a second example where we have the votes 1 2 3 4 and 5. Here each vote is repeated only once, so we're gonna print the output as -1, and there's an explanation. No candidate occur more than n by 3 times. We have a time complexity of order of n and the space complexity of order of 1. So now let's try to solve the problem here. um, to solve this problem, we'll use a modified version of a Boyer-Moore voting algorithm, which allows us to find the potential majority elements efficiently. So here we have a constraint that our approach should be with the time complexity of order of n and the space complexity of order of 1. So we need to make some changes to the code of Boyer-Moore voting algorithm. So let's dive into the coding part. Okay, now we have to check if the votes are empty or not. That means if the given array is empty, then we have to return -1 only. As we have given that, we need to return the -1 only. So okay, we are returning the -1 instead of an empty list. And now here we have also have the class of solution and the method of find majority. Here we been given a parameter nums, so we are checking on that. Now let me write the code for the following part. In this section we will initialize two potential candidates, candidate 1 and candidate 2, because we are going to check the majority of votes between only two candidates. And we loop through the array nums. So if the current number matches either candidate, we increment its count. If both counts are 0, we will assign the current number to one of the candidates. If both candidates are filled and the candidate number does not and the current number does not match, we will decrement both the counts. So I'll say candidate 1 and candidate 2. I'm taking these as two variables where I'm initializing with none and also none. Then I'm taking count variables, count1 equals count2 equals 0. So I'm initializing both the count1 and count2 values to 0. So I'm going to loop the array. I'm going to iterate over the array for num in nums. So I'm checking if candidate 1 is not none. Okay, so I'm checking if it is not none, and also we need to check another condition, num equals candidate 1. Then we are going to increment count1 value. Okay, so we have other condition, if candidate 2 candidate 2 is not none, and also num equals candidate 2. Okay, there is a mistake here. Let me correct it. Candidate 2. So in this section, we are going to increment the count 2 value by 1. Now we are going to check if count 1 equals 0. Then we are going to assign candidate 1 as well as count 1 with the values num and 1. Okay, elif. And we also have the condition to check for the count 2. If count 2 equals 0, then we are going to assign candidate 2 as well as count 2 equals num and 1. Okay, if the above conditions fail, then we are writing the else part. We are going to decrement the value of both count 1 and count 2. Count 1 I'm just decrementing the value by 1, and also for count 2 I'm just decrementing the value by 1. So let me tell you again what I have written in this code. I'm initializing two candidates, candidate 1 and candidate 2, along with their counts. I'm going to loop through the array, and if the current number matches either candidate, we increment its count. If both counts are 0, we assign the current number to one of the candidates. If both candidates are filled and the current number does not match, we decrement both the counts. So next, we need to verify our candidates. We reset the counts and loop through the array again to count how many times each candidate appears. Okay, so I'm just exiting the loop, and I'm just again initializing count 1 and count 2 equals to 0. And I'm checking again for num in nums. If num equals candidate 1, in this case I'm incrementing count 1 by 1, elif num equals candidate 2. In this case I'm just gonna increment count 2 value by 1. Okay, so finally we have to check if either candidate has a count greater than n by 3. If they do, we add them to our results. We return the result sorted in increasing order, or we have to return -1 if there are no valid candidates for the voting. Okay, so I'm taking n equals to length of nums, so I'm getting the size of the array. Then I'm gonna check if I need an array, right? I need an empty list. I'm checking if count 1 is greater than n by 3. I'm just making a flow division. Result dot append. I'm adding it to the result list candidate 1. I'm checking for the second candidate also if count 2 is greater than n by 3. In this case I'm adding it to the list of the candidate 2. Okay, then I'm just going to return the sorted array sorted of result if there are any elements in the result list, else I'm just going to return -1. Okay, now let me run the code. Let's see what happens here. Okay, there's a runtime error. Cannot unpack non-iterable object. Okay, maybe I should do it like this only. Count 1 and count 2, 0, comma 0. Oh, sorry. I need to write it here only. Maybe. Okay, let's check. Ah, right. Our output is correct with the expected output. Let me submit the code and check if it is working fine or not. Oh, there are two test cases failed and saying that memory limit exceeded. Okay, there is a large input file for this. Let me see where I can make some changes in the code and make it more efficient. So I made a small change here where initially I have initiated candidate 1 and candidate 2 with none comma none, and in the next line I have written count 1 and count 2 with 0 comma 0. So I changed that and initialized in the same line. Let me try whether this works or not. Basically this is a basic change, but sometimes it might work. Okay, let me check if this works or not. Yeah, this works. Great. Yeah, sometimes even a single line of code takes some memory. Okay, so that's okay. Let's see what happens, how it happens. Yeah, anyway, we have successfully cleared today's problem of the day in Geeks for Geeks, and that's it for today's problem session. So we efficiently found candidates with more than one third of the votes using the Boyer-Moore voting algorithm. If you found this video helpful, please give it a thumbs up and do subscribe for more coding tutorials, and also make sure to hit the bell icon so that you get daily updates of solving the problem of the day in Geeks for Geeks, and also maintaining the daily streak in lead code as well. And let me know in the comment if you have any questions or suggestions for future topics. Thanks for watching and happy coding. Keep maintaining your streak, guys.